try to do tonight in terms of the theme is to talk a bit about supply chain collaboration and the technology that made it possible, maybe, or maybe it was the egg or the chicken, I don't know. But we're there now, and it's something really relevant if you look at a lot of topics coming on the supply chain websites. Collaboration becomes very important. So I'm going to try and just on a high level explain what is the philosophy behind this. We do have a specific products that we support, but I'm not going to try and sell that. I'm rather more talk about the philosophy. In terms of functionality regarding the cloud, this slide is actually quite busy. So you can see once you get into a supply chain, there's a lot of functionality that you require. Being it, and I like to highlight in terms of the 4 areas there, being it the stores or the end client, the transportation providers, the carriers, all the suppliers and co-manufacturers and then the manufacturers. That's normally what we understand in the supply chain. It's from factory floor to garage door, or my buddy in Steinhoff says from forest floor to kitchen door, or whatever you guys call it in terms of the industry that you work in. But that's normally how you view a specific supply chain. So if you can think about that supply chain in a retail environment as instead of a chain but more of a network, and that's where you start off from. So if you look at optimizing a network, it's different than optimizing a supply chain. Okay, so suddenly if you start to optimize a network, there's certain aspects in the network that in terms of the supply chain would have been optimized, but in the network it's not critical. So the aim becomes bigger. I think the slogan here at the bottom says, the network is the solution. And when you start talking about collaboration, if I'm jumping the gun, and you can talk about collaboration regarding multiple companies across different SKUs. I'm trying to get your terminology right in terms of the forecasting and stuff, but you get the picture. It becomes a complex picture that you're actually trying to manage. Okay, so if you look at where it started in terms of a traditional approach, and when we talk about RTVN, it's actually a term coined as the real-time value network. So moving away from demand-driven supply chain or demand-driven network, I'm not sure who's familiar with those terminology, but if you talk about forecasting and replenishment in a supply chain, that's kind of the terminology of the day in terms of demand-driven. So we call it the real-time value network. It's kind of let's say it's a sense and response kind of network. But traditionally in a supply chain, you had the customer, the retailer, the distributor, manufacturer, the supplier, all doing their own thing. And it might even be that those guys was one provider, but they still focus on their domain. I'm going to try and tell Trevor's story because I'm not coming from the procurement side, but a certain company in South Africa brought out a new 6 series. Wonder who that can be. And when they brought out the series, they said, okay, but to be able to maintain this, we need wiper blades. So they brought in, let's say they brought in 500 new vehicles and 1,000 new wiper blades. So what did they do first thing? Procurement at central office, 1,000 new wiper blades. What happens? Distributed through the network, dealerships. Every dealership get 2 wiper blades. Do they need that? Not really, it's a new car. Okay, so there you go. Everybody working in his own silo. Then 2 years down the line, what happens? The car is old, the guy, he actually got one wiper blade not working, replace a wiper blade, goes to his dealership, dealer provided a wiper blade, suddenly safety stock has now reached its limit, he needs to order, he ordered 2, because he wants to keep safety stock up. So now this dealership orders 2 from the central depot has no wiper blades, and suddenly it realizes, I'm in trouble. So what do? They don't follow the supply chain, they actually jump the supply chain by flying in wiper blades from the country because it's now an urgent matter. And that's typically when you work in silos. So when you start collaboration, even on the chain, if you can break down the walls, it will just create better communication. We talk about, in the IT world, we talk about the system of record. In the industrial world, we talk about the single version of the truth. So that layer is where you start off with, so that everybody works from the same layer. And when you do some kind of optimization, you got one version to talk to. Another thing is in terms of the bullwhip effect. Okay, so what we did in the previous example, we actually jumped the bullwhip effect by just sending a plane. Because otherwise the lead times in terms of ordering central depot, going to the carrier, going through the normal processes, would have just escalated in terms of the bullwhip effect, getting through the process, and every time it just becomes longer and longer and longer in terms of replenishing the specific wiper blades. So if we can reduce the bullwhip effect and make it more effective, just with collaboration, that already has a huge impact in terms of the supply chain. Okay, so traditional planning, the planning and the execution are not aligned, and you can't really execute a plan. It's almost like the retailer plans something, and after a week he sends it to the DC. The DC then batch it after a month, send that to the supplier sends it to the manufacturer. That's the whole bullwhip effect. At the end, the guy who creates the plastic containers for yogurt has no idea what to expect. He can't produce it quickly, so he's making 1,000 of it, just to be able to carry that stock. So the guy's understanding just in time, I think this relates a bit into just in time. So typically that's what you sit with. Or you sit, as I just explained, you sit with batch data. It gets batched on the end of the day, end of the month, end of the year, okay, hopefully not that long. And then it goes through the bullwhip effect again, because it gets aggregated at the next level and aggregated at the next level. Okay, concentrate, the next one is quite quick. So what we have is something like that. Okay, so I struggle to see this as well. If you look at the frequency of the demand signal and the response signal, they actually a bit wide. So the communication is removed from each other. But if you then start to clear it up with collaboration, you will see that it becomes in sync. So immediately, demand sensing and response is much better. In this situation, the enterprise part is where you play the role. So your noise, your variability is much less because you actually filter that out. But in terms of suppliers and customers, there's a lot of variability. So you either order too much or too little, and you don't know. Or you manufacture too much or too little. So what we're trying to achieve is then create better communication and move it closer together in terms of the sense and response. So that's ultimately where you want to end up. Now variability changes. Because the communication is open, collaboration is better, and the variability reduces. And because of the variability that reduces, it's a much better supply chain in this instance that we're talking about. Typically, the guiding principles is it's a community, as I explained in terms of a network. So you become part of the network. Maybe Andrew will talk a bit about permissibility and what you're allowed to see. But the fact is, if I'm Clover and it's my yogurt standing in Pick and Pay, I'd like to know what happens to my yogurt so that I can do my forecast much better at the manufacturing side. And when you start to collaborate, it's much better. If you just look at one vendor, let's say you Pick and Pay, you got 20 stores and you got 50 yogurts at the one store and 10 yogurts at the other. And I've got an order in at my 50 store for another 50 yogurts, and it's a high order. The priority might go to the 10 order guy because in terms of the stock on hand and the network visibility, you can see that my depot only have 20 available. So not sending the 20 to the priority of the guy who wants the most, but rather to the guy who needs it most. Something that concept becomes now viable in terms of a supply network. If you really get this thing to the ultimate, you can start working on the sales forecast, the POS, the point of sales. So the moment you sell something, that detail comes into the system, and you can, as a Clover at the manufacturing side, can respond, and you can make your own decisions. Obviously, this is very high level that I'm talking about. There's a lot of things influencing that, promotions, seasonality, and all of that. But the idea is that you have a sense of the network and what's happening in the network and what's happening in your part of the network. For the industry is then to embrace this kind of technology, because now suddenly you're obviously going to share competition on the same network, although there might not be visibility, and Andrew can explain a bit about that. But the fact is, for a Pick and Pay, it's important to see a Danone versus a Dairy Bell versus a whatever in terms of yogurt, because at the end of the day, they want to achieve on-shelf availability of a product. That's customer service. That's the end goal that they'd like to achieve. Okay, so just a mimic in terms of how it works or one way of implementing it. It's not necessarily replacing ERPs. The ERPs can still be there, warehouse management systems, procurement systems, but it's getting those feeds from the ERPs, from the different systems, into the network, and then get the network to collaborate. So typically, this is just an example of the application if you want to mimic a network, and you can immediately see this is actually a simple example because there's a single link in the middle, and the rest of it just spans out. And you can, some of those numbers, you can see the stock on hand, so you can immediately see at the store on the left-hand side, that's my stock on hand per store. At the DC, that's my stock on hand. At the central DC, that's my stock on hand. And you can see what is your network capability in terms of providing a specific product. And that makes the design much easier. I'm going to stop with this slide because I think Andrew is going to get into this. But typically, as I said, it's an embrace philosophy that you can tie into your existing systems, get the data into the network, and then collaborate on the network from that point of view. Short and sweet.
So I think I'm going to jump right in. I'm going to pick up on quite a few of the points that Alvain made in his slideshow, so I hope this rolls it up quite nicely. So just to recap on the traditional supply chain, Alvain's spoken about this a little bit. There are very complex problems that we work with: routing optimization, load optimization in trucks, inventory forecasting, things like that. And when you come down, when you look at it from a computer science perspective, the type of algorithms that you're going to be implementing to solve these problems are generally, they're called exponential algorithms. If anybody's looked at different types of algorithms, you get linear, logarithmic, and things like that. And each one of those different types of algorithms requires different types of computing, different times to run, things like that. And unfortunately, exponential is the worst. The more data you add, it gets exponentially longer and requires exponentially more resources to actually process that data. The traditional computing approach, what we've had now is you've got the ability to add more CPUs. You've got the ability to add more memory, cope with the more amount of transactions you need to, or at least computations that you need to do, cope with the increased data, and then you wait. Because these things can sometimes take forever to run. The problem with that is the approach can only go so far, and even often the system that you're busy using is generally becomes unusable during that time that it's running those calculations. So you run this massive forecast, you end up with all of this data, and you might get an order or two the next day or something like that throws everything out, and you need to rerun it and wait and all those types of things. Now, to contrast that with the modern supply chain that Alvain has been speaking about, there's this drive to increase collaboration across the value chain. There's lots of integration with different systems. The problems are no longer being solved in silos. You're trying to work with your different partners to get a better view of the world and to try solve these problems a little bit better. But that just compounds our problem because the problems then become more complex. Adding even just one extra data set can, exponentially increases the processing time, the memory requirements, and things like that. And, the real issue is that access to that information is critical in order to make decisions and, try and keep you sort of ahead of the pack. If you look at the modern computing approach now, so to try and solve this problem, we have to try and think differently. We can't just throw more processors at the thing, throw more memory at the thing, and hope to come out with a better result. So modern computing approach, big buzzwords like big data and in-memory computing and things like that, all different approaches to how you manage your database, how you actually run transactions on your database. They're mind shifts. It's quite a big change, but again, these can also only go so far because again, you're still sitting only with your data per se, and you can calculate these things much quicker and things like that, and it's fantastic, but it still doesn't optimize the network. So, like I say, you're still physically, constrained by the physical limits of the server. It's very difficult, even with these approaches, with newer databases and in-memory computer, it's very difficult to do parallel processing. So often if you look at the way to solve a routing issue, like a traveling salesman problem, for example, you need to create a bunch of agents that go out and do all of these calculations, report back their findings, and then pull this result together and figure out which one was best. So, you can go and execute each agent one by one, and that will take a long time. You can execute them in threads, and try and multitask it on the processors, but again, then you're still limited by the actual CPUs themselves. So, even with these newer technologies, it's still difficult to support the collaborative view that we're going for today in the modern supply chain environment. So what's the answer? Cloud computing. Is it the answer? So take a look at cloud computing. Some of the advantages that you get. One of the biggest things that you can get to when you move towards the cloud is load balancing, and not necessarily just load balancing on networks, but load balancing across different machines. What this allows us from a computer science perspective, it allows us to manage the system resources more evenly. You find often accessing a little bit of information to present on a UI, for example, is a very small task. But if the system is busy processing other tasks, that task still can take a hell of a long time to run because it's waiting for a forecast to finish or something along those lines. So it allows the system to be more interactive. You can also do parallel task execution with concepts like grid computing. So the idea there is to rather add more nodes that can operate independently of each other on the same data, and then purpose nodes for one use purpose, purpose these for UI nodes, for example, and these for actual processing nodes. And it also becomes a lot more easy to use some advanced technologies like business rule engines. If anybody's ever coded or worked in the Java space, there's some technology called joules. I know we have these fantastic names for things, joules, but the idea there is that you can abstract your business logic and put them into nice sort of compact rules. So you can take all of your computations that each one of these agents would need to do, for example, in your traveling sales problem, and implement them as business rules. And then throw each one of the agents at these business rules, and then just take the answers from that and collect them. So now what we can do in this sort of approach is we can parallelize that and run that on a bunch of different nodes and allow those agents to execute a bunch quicker and give us an answer a hell of a lot more quickly. Also, just some of the advantages: your servers can be virtualized, lower administration effort on servers. You can easily clone servers to reduce the setup times and things like that. So it becomes a lot more cost effective. And then in this scenario, if you deploy it correctly, you can then change your system and scale your system to meet the needs of the users that are busy running it. So you can repurpose nodes. So for example, if you find, sort of towards the end of the month, this is generally when a bunch of orders come in and things like that, and we're going to have large impacts to our forecasts. We can take some nodes and repurpose them from handling UI transactions to handling the computational transactions that are required for the forecasts. So the systems can generally be more highly available as well. You can have a typical scenario where you're running in a sort of a client-server world. You've got one server, client is connecting to that one server. If that server is unavailable, then you're a bit buggered. In our case, in the OneNetwork case, it's the interface is web-based. So we stick a load balancer in front of that. Actually, I'm going to talk to it on another slide, but we stick a load balancer in front of that and load balance across multiple UI nodes, so that if those UI nodes, if one is busy, we can throw it at the next one, the next one, the next one. There's a bunch of different algorithms that we can use there. But yeah, so the main point there is that it allows the system to scale horizontally. So you're no longer limited by the physical capabilities of the machine itself. You can just add another machine that has the same capability on the side without affecting the system architecture at all. So how do we do it? We still have our traditional database. That's not going anywhere. Obviously, you can move to different databases these days. You could look at some big data databases like MongoDB or something along those lines. And then typically now we throw a bunch of processing nodes in front of there. So again, I've put up quite a couple, because then what we do is we go and we say, all right, we're going to take one, purpose it as a node that just handles the authentication of the different users and the different transactions and things like that. We'll take 2 nodes for UI processing, for example, 2 nodes for task processing. So all your user interaction is handled on the one side, and all of your complex problem solving is handled on the other side. So no matter what's going on the user interface side, it's not going to affect the complex problem solving, and no matter what's going on in the complex problem solving, it's not going to affect your UI. We then throw a load balancer in front of those, like I was saying. So now we have the ability to provide a highly scalable system that's highly available to the users in real time, whilst still handling solving complex problems like forecasting. And obviously, as those demands increase, you might just add more task processing nodes, for example, to provide extra processing power for that. So, I mean, good examples of this: Google and Amazon. They generally implement cloud computing very well. Amazon even offer cloud computing as a service now, where you can just throw up a bunch of servers as required, and they manage them all for you. But then closer to home, as Alvin was talking about, now we use OneNetwork. So OneNetwork is really a platform rather than a software product. It was one of the things that they realized. It came out of the I2 space. The CEO, Greg Brady, is from I2. He realized, okay, well, what we're going to have to do, rather than just try and implement a software product, is actually implement a platform that can support these types of applications. So it's a framework for hosting these intelligent, agile, many-to-many networks, where you allow collaboration between your both stakeholders from within your company, as well as your partner organizations. All the entities on the network then collaborate on shared data. So there's no one company has their one little bit of data, and then they only decide, I'm going to give you this little bit and that little bit. So the data is shared throughout. But then obviously permissibility becomes an issue. So there's a very strong permissibility layer where you can decide what is available to other people to see, things like that. But also what that allows is, what Alvin was talking about a little bit earlier as well, is like vendor-managed inventory, for example. So you can have Clover actually manage the inventory in Pick and Pay. You can hand that over to Clover, and Pick and Pay doesn't need to worry about it anymore. They can see exactly what's on shelf and things like that, and then send through orders down the line and handle the logistics of getting it there. So essentially, the different entities on the network work as a team to solve this problem, rather than working in their different silos. So just a high-level overview of the platform. The core, that middle layer, it's a little bit of a simplified version of it there, but essentially what the core allows you to do is to model processes and then vary those processes according to the different organizations that are on the network. Provides the UI layer, provides the permissibility layer, and it also provides the grid computing. That IXM term, I'll explain that a little bit in a few slides. There's also a single sign-on provider. So there might be, Alvin was talking about a little bit earlier, there's the real-time value network, there's the logistics network, and they typically solve 2 different problems, the one of forecasting and the other one of the logistics of moving those orders around. But here you only need that, you can sign on with one sign-on, and you've got access to each one of those applications, which is quite nice. There's a very strong integration component as well. Oftentimes, as Alvin was saying, you aren't going to replace the person's ERP. You're just going to integrate with that company's ERP. So we do all the nice stuff like web services, SOAP and REST web services, for example, support legacy file transfer and things like that. And then basically from the core of the platform, that's where you build out different modules. So the module A, module B, module C kind of thing would be things like real-time value network, transportation management system, things like that. And the nice thing that we have, being a partner of OneNetwork, is we have the ability to extend those modules and build on other modules as we see fit. There's a couple interesting Africanisms that come up, like the fact that truck drivers stop on the side of the road, siphon diesel, and sell it. they don't deal with these problems in the US. So, but we have to deal with those here in South Africa, unfortunately. So just a quick look at the computational grid. So the platform is specifically architected to function as a cluster of nodes. So you can run it on one server, you can run it on 10 servers. They all use the same database, they all work in unison with each other. And then you can take those nodes, like I was saying, you could purpose them as UI nodes, integration nodes, planning and execution nodes. And then multiple nodes can also perform the same function, like I was saying. So essentially it just ensures that horizontal scalability. One of the big aspects is the computational grid controller. So what that does from a development point of view, what we do now is we take each one of the problems and break them down into smaller tasks. And then we can farm those tasks out to any node that's available, configured to be able to process those tasks. So the computational grid handles that delegation. It tries to do it as asynchronously as possible. So it will try, if it can, it'll send out, if there's 15 computations that need to be done and there's 15 available nodes, it'll send to all 15 nodes at the same time, and then handle the synchronicity of combining everything when it comes back on the grid controller side. So you don't need to execute one task and wait, execute the next task and wait, execute the next task and wait. And then, it can handle both real-time and scheduled batch tasks. So one thing that I mentioned a little bit earlier, it lends itself very nicely to continuous forecasting. So if you have it set up nicely, you can take signals from, like Alvin was saying, from your point of sale, and you can forecast it or change the forecast right the way back to the suppliers and manufacturers. So, and then, like I say, get that in sort of very near real time, because the computation is happening right there as the sale happens. Integrated execution management framework. This is just a little bit of a layer that's built on top of the grid computing. So essentially, it's built to specifically handle the planning algorithms that we encounter in supply chains. So it typically supports this, creation of agents and whatever, and then delegating those tasks out, letting the agents run them, and then bring them back. You can do scenario simulation, which is quite nice. Collect and compare the results. What if I were to go with a 10% discount or a sale or something like that for the next month? How would that affect my supplier further down the line? So obviously, just very, very good for supporting the decision-making and planning functions. So, just in summary, by combining the virtualized load-balanced infrastructure and a platform specifically architected to take advantage of multiple nodes, grid computing architecture which leverages the parallel processing capabilities across those nodes, OneNetwork provides a nice, resilient, scalable cloud computing platform suited to solving these modern supply chain problems.